So I'm going to do a couple of these. I'm not going to do all of them. I'm just going to do enough to show you what's going on and explain what's going on, and I'm going to give you some to practice because I've made duplicates of these all, and I want you to be able to practice on the duplicates, or if not, practice on the ones that I do as well if you want to try to repeat them. So in this first one, all you're trying to do is you're trying to reduce the following. All that means is to get it into the smallest form possible. And what that usually means is that you have to combine like terms. Well, in this first one, you'll notice that you have two types of things. You have a I, meaning that it's connected to a number, or you have a number that's not connected to an I. So this is what's known as like terms. The things that do have just a single I are like terms, and the thing without anything period besides the number itself are also like terms. So what we're going to do is we're going to combine these together. This is a positive 5, and this is a positive 7. So what we're going to do is we're going to combine those together. Well, if you take $5 and add it to $7 or put them together, you end up with $12 total dollars. Now this next one, you have to realize that this 9 is negative and this 9 is negative. So when we take these two 9s, we have to say, okay, this is negative 9 and negative 9, so you add them together. It gives you 18, and since they're both negative, it'll be negative 18. Technically, this is not the right order. It should actually be 18 plus 12i. But most of the time won't count off for that since you guys are still learning most of this. So this problem is just like this problem down here, so I want you to practice. And then I'm going to scooch over to this one, and I'll give you the answer to the next two. So on this one right here, what you'll notice is we have a number in front of a parenthesis. Now, we have to look at the number in its entirety, and that number means the number itself and the sign before it. So right now, this is a negative 3. And since this is next to a parenthesis, what we have to do is we have to distribute the 3. The 9i doesn't change, so it just brought down. Negative 3 times 6 gives you negative 18. Negative 3 times positive 4 becomes negative 12i. And then you subtract 3. Our next step is to combine like terms. So that means that we're going to combine this thing together with this thing because remember, they do not have i's, so they're like terms. And the two things with i's are like terms as well. So this first one is a 9 plus a negative 12, or just 9 minus 12. That gives me negative 3i. Then you have negative 18 plus a negative 3, or just negative 18 minus 3, which gives me negative 21. And remember, technically the correct direction is to have the non-I number in front. That's how you do that. So I'm going to quickly do the next one just to show you the answer, but that's all that's going to happen. So let's quickly do this next one. Okay, so the two like terms are here and here, so this will become positive 1 plus 1i. This one right here, if we distribute the 6, it becomes 11 minus 30 plus 24 plus 13 will give me negative 19 plus 37i. And that's how you do those. Now these next couple have a little bit extra, okay? So this first one now says 5i. This is the first time that we're distributing something with an I. So it's in front of the parentheses, so we're going to distribute it to both these two ideas, or objects. This becomes 15i, and this becomes negative 30i. Now, since I have one I here and one I here, this actually becomes I squared. And we get into the next part of our knowledge, which is that I squared is the same as negative 1. Because remember, I is the square root of negative 1. We write that instead of having to put square root negative 1. So in this case, we have 15i minus 30i squared. So I'm going to change that I squared into a negative 1. So what we have to do now is take this negative 30, multiply it by negative 1, which gives me a positive 30. And since it doesn't have an I anymore, it's going to go in front, and the 15i is going to go behind. Okay? Alright, next one. You're going to do, and I'm just going to quickly show you the answer. Okay, so the answer should be negative 16 minus 12i. That should be the answer to that one. Alright, going on. So now, we have these ones where you have the two parentheses. Instead of just one, now we have two parentheses. So technically what we're going to do here is we're going to do the box method. I'm going to show you the box method, but I'll show you what we're actually doing, which is just the faster way to do it, but it becomes more confusing if you don't know what you're doing. So, we're going to start with the box method. Remember, the box method, we figure out how many terms are in the first one and how many terms are in the second one. We have 2 terms in the first, 2 terms in the second, because we have 1, 2, 1, 2. So we're going to make a 2 by 2 box. On the top of the box goes the first thing, so that's minus 3i. Side of the box goes that. Now, what's special about these is wherever they meet, they multiply. So in this case, it'll be 6 times 4 is 24. 6 times negative 3 is negative 18i. 4 times 4 is 16i, and 4 times negative 3 is negative 12i squared. So now I'm going to rewrite these numbers out here. That's 24 minus 18i plus 16i minus 12i squared. So now we just need to combine like terms. These two are like terms. This gives me negative 2i minus 12i squared and 24. And then we got to notice one thing. We still have an I squared. So remember, that's a negative 1. So what we're going to do is we're going to end up with negative 1 times negative 12, which will give me a positive 12. And the I squared goes away. So essentially all it does is change the sign. If it's negative, it becomes positive. If it's positive, it becomes negative. Last but not least, let's combine our last two like terms to get 36 minus 2i. So that's the box method. Now, technically what we're doing, I'm going to show you on this one, is we're distributing twice. First with the first number, the second with the second number. So I would distribute this 8 to these two things behind here. So let me sharpen this real fast. Alright. So this 8 times this 9 becomes 72. This 8 times this negative 4 becomes negative 32. I. Okay, and then this 5i times this becomes positive 45i, and then 5 times negative 4 becomes negative 20i squared. Okay, so remember this is just going to flip the sign, so they'll become positive 20. This is 45i, it's 32i, 72 minus. So these two are like terms, which becomes 92. These two are like terms, which becomes 13i. That's what your final answer would be. So you either can do it my way, this way, or you can do it the box method. Both will work, both will come out with the same answer. Now if we turn the page, what we're doing is we are reducing the following by multiplying by the conjugate. Okay, so the conjugate, if you remember, is the opposite sign for only I. So what I mean by that is that we have a positive 3i here. So to multiply by the conjugate, we have to multiply it by the negative 3i. Now, you can't just multiply the bottom because that alters the equation. So we have to do the same thing to the top, because technically this is 1, and anything times 1 is itself. So we're not actually changing the property, or we're not changing the total configuration, but we're just multiplying by 1 technically. Why we do this is because we're trying to get this I from the bottom. For some reason in math, we don't like to have some things in the bottom of the fraction. So what we do instead is we try to eliminate that and keep it in the top of the fraction. So we multiply 8 times negative 3, which gives you negative 24i, over 3 times negative 3, which is negative 9i squared. Now, remember, this flips the sign of this, and then this goes away. So this becomes negative 24i all over 9. Our last step is a thing, what can I divide both the top and the bottom by so I can reduce this fraction? Well, I can tell you if you take the top and the bottom and divide it by 3, you can get, it will go in evenly for both. So your end answer will be negative 8i over 3. Notice how the I moved from the bottom to the top. Okay? Second one I'm going to have you do. Pause the video, try it, and I'm just going to show you what the answer is. Okay, so this should be 16 over negative 40i, which is technically going to break down into negative 5i all over 2. Now this next one right here is a little bit more tricky. The reason is because a lot of people, when they hear change the sign, they try to change the sign of the 4 as well. Once again, we're only changing the sign of the I on the bottom. So what we're going to do is you're going to multiply by 4 plus 6i, both the bottom and the top. So I'm going to do this top first. What this is saying is you're taking 2i, multiplied this by this whole thing. So what we have to do is we have to distribute this to both ideas. So it becomes 8i plus 12i squared, which this will turn into negative 12 plus 8i, because remember, this changes the sign of this, and then it goes away. That's the top part. Now the bottom part, we'd have to do the box method in order to solve. So when I do this box method, let me show you what happens. So when I get 4 minus 6i, I do 4 plus 6i. Where they meet, they multiply. This becomes 16. This becomes negative 24i. This becomes positive 24i. And then this becomes negative 36i squared. Well, these two are the same thing, but one's positive and one's negative, so they cross out. And this becomes 16 minus 36i squared. Well, this will turn into 16 plus 36, which will end up being 52. So I have 52. On the top is negative 12 plus 8i. Now, we're not done because once again we can reduce everything. So I'm going to figure out what's the biggest number. They'll go into 12, 8, and 52, and that number is 4. So this becomes negative 3 plus 2i all over 13. Okay? So I'm not going to do these bottom three because this is just a repeat of the last one. And these two, you're going to do the same idea, but you need to do the box method for both the top and the bottom. So let me show you what I mean. So this one would be the box method of 4 minus 9i, and on the side will be the conjugate, which would be 3 minus 7i. And you have to do that whole thing, and then you're going to have to do the box method for this and the conjugate in order to solve for it all. Okay? Now the next part you have to use the quadratic formula. Okay? So remember, we have ax squared plus bx plus c is what the standard form for a quadratic is. The quadratic formula is negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. Okay? Now, all of these numbers we can get from the equation themselves, and what these do is they help us find the roots, the complex roots, or technically the complex zeros for this. So what I'm going to do is I'm going to first find my a, b, and c. My a is always in front of the x squared. If you don't have one there, it becomes 1. My b is in front of the x, so that's negative 6, and my c is 13. So if I plug all these into my formula right here, it starts with a negative sign, and then we put the b. I'm going to make you put everything in parentheses just so you can figure out what's the difference between a symbol that's with the equation and a symbol that's part of the a, b, and c. And this will be negative 6, and we'll square that. Minus 4 times 1, which is a, times c, which is 13, all over 2 times 1. Okay? So now I'm going to simplify this all. 2 negatives makes a positive 6. Plus or minus the square root. Now I'm going to put this part in my calculator, parentheses and all. So what I'll do is I will put in negative 6 minus 4 times 1 times 13. That gives me negative 58. Now, I made a mistake. What you'll notice is that I forgot the squared portion right here. So if I press second insert, I can just put the squared there, and everything should be out. Now, that's the number I actually wanted, which was negative 16. So I'm going to put negative 16 right here, and put this all over 2 times 1, which is 2. Now, if I ever put a negative number into my equation, or into the square root, it comes out as an error. So what we're going to do is figure out what the square root of a positive 16 is, and since this has a negative, we're just going to put an I afterwards. So the 6 becomes 6 plus or minus, and then the square root of 16 is 4, but because it was negative, we're going to put 4i, and it's all going to be over 2. Now, since these are all actually divisible by 2, we can just simplify it like so. So we'll take 6 and divide it by 2 and get 3, plus or minus 4 and divided by 2, we get 2i. Those are our two zeros. It would be 3 plus 2i and 3 minus 2i. Now, sometimes the number in front is bigger. So, what I'm going to do is I'm going to still find my a, which is 25, my b, which is 30, and my c, which is 58. I'm still going to plug it in as negative b, which is negative 30, plus or minus the square root of 30 squared, minus 4 times 25, because remember the a is changed, times 58, all over 2 times 25. So what happens is we get a negative 30 plus or minus the square root put that all in my calculator, end up with negative 4,900 all over 50. Okay, if I simplify this, remember I only can look at the square root of 4,900, not the negative part. I get negative 30 plus or minus 70, and since of this negative sign, it becomes an I all over 50. And I can tell you right now, all three of these things are divisible by 10. So 30 isn't divisible by 50, and 70 isn't divisible by 50, so we can't do the same thing we did in the last problem, but we can reduce all of these by 10. So if I divide 30 by 10, dividing everything by 10, I get negative 3 plus or minus 7i all over 5. And so that would be my answer, is those are my two roots. Now for this last part, what you'll notice is that now we're going to find the zeros in the y-intercept, then graph them. So before we get anywhere, let me explain something so that it becomes easier to graph later. If we have our lead x, that means this x right here, if it's x to an even power, our endpoints are going to go out like so. They're going to curve up and go out. If it's a negative x, meaning this number in front is negative and it's even, instead of going up, those two things will go down. So if we have x odd, the left one will go down, the right one will go up. And if we have negative x and it's odd, then the right one will go up. The left one will go up and the right one will go down. And it'll look like that. Okay? Now, a lot of you guys try to curve it back like this. That's not correct. I'll show you the correct way when I graph the first one. Now, I'm only going to do 3 of these. There's 5. I'm going to do 3 that I feel like are probably different, so that way you can just figure it out from there. So first, I'm going to look at 54. So this is the number I care about. And so I'm going to break this down. I'm going to figure out what are all the numbers that can go into 54. So I know 1 can go into 54, and I know 2 can go into 54. So once I keep going through this, I know that 3 can go into 54. 4 cannot, 5 cannot, 6 can, 7 cannot, 8 cannot, 9 can, 10 cannot, 11 cannot, 12 cannot, 13 cannot, 14 cannot, 15, so on and so forth, till we get to 18 and 54. 18. Well, 18, then 26, then 54. Okay. So what we need to do with all of these is we got to replace x with each one of these until we find one that will work for this. So what I'm going to do is I'm going to shortcut this. I'm going to show you what it means when I tell you to plug something in. But I'm going to shortcut it and just give you the zeros that will work, just so I don't have to sit here forever to show you what's going on. Okay, so, whoops, try to get this in position so that you can see both what I'm doing and the calculator itself. Okay, so what you'll notice is that we have x squared. Now I'm going to try -6. So what I do is I put in parentheses -6 and then I square it because that's what the first thing tells me to do. Since it's x, we're replacing x with -6, and that's all that's going to happen. So let's do -3 and then put a -6 in parentheses next to that, and then -54. What you'll notice is that this comes out as a 0. That's what we're looking for, is something that will make it 0. So that will make it 0, so I'm going to do that. So I'm going to put -6 right here. And now what I'm going to do is I'm going to put the coefficients of each thing in order. So I'm going to start with x squared. What was the x squared one? Well, that was 1 because there's nothing in front. Then I have to go to the x, which is -3, and then which x is technically is x to the first power, and then we go x to the 0 power, which is the one that without an x, which should be 54. So what we're doing right now is called synthetic division. We use this to divide the number out so we can find, so it becomes a little bit easier when we're trying to find the rest of our zeros. So the next thing I'm going to do is I'm going to bring down this 1. Okay? I'm going to take this 1 and I'm going to multiply it by the -6. So 1 times -6 gives me -6. I'm going to put that number under the next part. Okay? Then I'm going to add these two downwards. Negative 3 plus negative 6 gives me negative 9. I'm going to take this and I'm going to multiply this. And negative 9 times negative 6 gives me a positive 54. This is technically supposed to be negative 54. And then when you add these two together, you get 0. This is your remainder. If this is not 0 when you're done, you did something incorrectly or you didn't find the correct 0. So what we need to do next is we need to look at what was the highest exponent from the last synthetic division we did, which was x squared. We need to go one lower than that, so we need to start with just x to the first, or what's known as just x. So this is going to be the coefficient of that one. So this will technically be 1x. And then we need to go x0, which this will be my x0, which is minus 1. The proper way of writing this is anytime you have a 1 in front of a variable, you don't put it there, so we'll just have it like that. Now this one's easy enough that we can figure this out pretty easily. We got to figure out what minus 9 gives us 0. Well, I can tell you 9 minus 9 gives you 0. So we know our zeros are negative 6 and 9. And we can tell we only have 2 zeros because this is only an x squared. If it was x cubed, you have 3 zeros. X to the 4th would be 4 zeros, so on and so forth. Our next thing we need to figure out is what is our y-intercept. Our y-intercept is found pretty easily. All you have to do is instead of having an x, you put a 0 in. So what ends up happening is that anything with an x turns into 0, and anything without an x is going to be your answer. So in this case, this will become a 0, this will become a 0, so your y-intercept is negative 54. Okay. Last but not least, let's look at what the end behavior does. It is x and into 2, so we know it's x and it's even. So we know our endpoints are going to go up to the left and up to the right. So I'm going to first put my zeros down, which is negative 6 and 9. Now, because of my endpoints, I know this one's going to go up, and I know this one's going to go up. What else I know is that we have a y-intercept way down here that's not actually on the graph. That is negative 54. So I know that this needs to connect to this, and then that needs to connect to the next 0. So what I'm going to do is I'm going to connect them with a U shape. So it's approximately, it's not 100%, but it's approximately what our graph would look like if we were to actually graph a bunch of points and figure out what it's doing. The next one I want to do is this one right here. The reason why I want to do this one right here is because it's missing something. What you'll notice is you have an x3, an x2, an x, but you have no back part right here. There's going to be equations that are missing one of the parts. So what we have to do instead of just regularly solving, we've got to realize I got to add a 0 right here. If it was the x squared that was gone, I would have to put 0, x squared, so on and so forth. But in this case, it's this back part that is 0. Now what's fun about this one is that I don't actually have to do much because there's only one multiple of 0, and that's 0. So when I do my synthetic division, I can just put 0 up here. My coefficient to that is 1. Coefficient to that is negative 3. Coefficient to that is negative 18. Finally, my coefficient to that is 0. And we do the same process. We bring down the first number, put it right here, take that, multiply it the outside number, you get 0. Add negative 3, multiply by that, becomes 0 again. Add negative 18, multiply that by 0, you get 0. So 0 plus 0 equals 0. And remember, that last number is our remainder. If that's not 0, we screwed up somewhere, but in this case it is. So this time, this started with x3. And remember, the x3 means we have 3 zeros. Then we went to x2, we went to x1, and then we went to x0. So now we have to start with the next largest term, which was x squared. And since this is a 1, this would be 1x squared minus 3 times x to the first minus 18x to the 0. Now let me clean this up so that it actually looks like what we're trying to work with. This, you don't put a 1 in front of anything. You don't put a 1 next as an exponent. And anything to the 0 power just goes away, so it's just minus 18. So now what we're going to do is we're going to figure out what goes into 18 and break that down. So I'm going to do plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18. Once again, to speed up with time, I know what the 0 is. I would technically plug these in until I figure out what makes this one right here 0. But since I already know the answer is negative, or positive, yeah, negative 6, I'm just going to plug it in. Okay. So it's negative 6. This is the new one's a 1, a negative 3, and a negative 18. So bring down the 1. That multiplies negative 6. Add those, negative 9. Oh, I'm sorry. Negative 6 doesn't work. Do apologize. What is it? It's actually negative 3 that works. Sorry, that should be negative 3. That adds together. That gives you negative 6. That multiplies to give you a positive 18. That gives you 0. Okay, so now remember, this is x squared, x1, x0. So we need to start with x1. So it'd be x minus 6. So we have 2 zeros so far. A 0, negative 3. Now our last one is going to be what makes it a 0, which is 6. So my 3 zeros are 0, negative 3, and 6. Now, my y-intercept is, once again, you plug in 0 for all the x's. So essentially, you just make these 0. That's 0, 0, 0, and 0. So since they're all 0, my y-intercept is 0. Okay? So let me graph everything. So my 3 zeros. My endpoints tell me this one goes up. Tells me this one goes down. And now my y-intercept is the same as the 0, so that's okay. So now what we have to do is we need to snake through. So we need to make a little snake that goes like that. And then this needs to snake and go up like that. Okay? Once again, this is not 100% perfect, but it is an estimation of what the graph would look like. Alright, the last one I wanted to do was something that had a number in front of the front x, just so that we can see what's going on with that. So I'm going to do the plus or minus stuff. 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. I'm going to figure out which one of these makes a 0 real fast. So I'm going to plug this all in real fast into my sorry, it's just going to be random. It's going to be awkward pause. I can fill it with random space like me just talking until I get the thing. Alright, so let's see what makes the 0. Alright, now one of my zeros is negative 4, actually. So, I'm going to start with negative 4. And then I'm going to do this whole synthetic division thing. So this becomes negative 3, negative 14, negative 13, and negative 20. Bring stuff down. Do the whole bang, everything. Into with the 0, so that means that everything's good. And since this was x cubed, I need to start off with one lower than that, so that's x squared. And since negative 3, I'm going to do minus 2x minus 5. Okay? Then I'm going to do this again, figure out what makes this 0, and I can tell you right now it's either going to be 1 or it's going to be 5. Sorry for the awkward pause again. Okay, so negative 3x squared minus 2x minus 5. Second table. Huh. I guess I made one that has only one real zero. Huh. Well, that sucks. Alright, well, pretty much the first two are going to be like the ones that are going to be on the test. This last one's not really going to be on the test. So, please study. If you need any help, feel free to email me at Kevin Horak or Kevin_Horak at dpsk12.org. I can help you out. If you want to call, we'll do whatever. We can figure something out. All right, thank you for listening. Bye.